This is geometry. This is day 11, angle pairs relationships 3. We're going to be working with the information we learned in the past about if you have two lines parallel, then alternate interior angles are congruent. We also learned that consecutive interior angles are supplementary. Corresponding angles are congruent if two lines are parallel. And then, of course, alternate exterior angles are congruent. Those are all found in our previous notes. What we're going to prove right here, we're going to prove the theorem about the alternate interior angles. If two lines are parallel, then alternate interior angles are congruent. We're not allowed to use that in this proof, but we're going to prove that that works. Therefore, we can use it in the future. So we're going to start out with the given that we have parallel lines. That's our given information. What we want to prove is that 1 and 2 are congruent. So P is parallel to Q. That's our given. If P is parallel to Q, I can't say right now that 1 and 2 are congruent because that's what we're trying to prove about this alternate interior. So I'm going to be able to say that corresponding angles, that's our postulate, we can always use that one. So our corresponding angles are congruent when the lines are parallel. And because 2 and 3 are congruent, that makes 1 and 2 congruent. So 1 and 3 are congruent if lines parallel, then corresponding angles are congruent. Now let's think here. What would go in this spot? We've already said that 1 and 3 are congruent. What could possibly go? It looks like the information they're giving us is talking about vertical angles. If two angles are vertical, then they are congruent. So that would have to be angle 2 is congruent to angle 3. Now if 1 is congruent to 3 and 2 is congruent to 3, why can we say 1 is congruent to 2? It's not substitution because you can't substitute with congruence, but it is transitive property of congruence, POC. So what we've done here, we have proven that when you have two lines parallel, that alternate interior angles will be congruent. And from the future, we can use that statement. Now on the flip side, what we're going to prove is that alternate exterior angles. Oh, we're going to prove the converse. Alright, to prove the converse, what we actually need to do, we need to discuss the converse. The converse back here is found on the previous set of notes. What the converse is talking about is the converse of each of our statements we learned yesterday. If two lines are parallel, then alternate interior angles are congruent. Now what we're going to say is if alternate interior angles are congruent, then the lines are parallel. That's the converse. Listen to the difference. If alternate interior angles are congruent, then lines are parallel. Now, I did leave out the transversal part because you don't have angles unless you have a transversal, so just trying to keep this if-then statement as small as possible. You have to say the name of the type of angles. Okay, the same thing true with the exterior. If two lines are cut by a transversal, so alternate exterior, the word exterior in there, alternate exterior angles are congruent, then the lines are parallel. So what we're doing here is we are actually proving lines are parallel. When will the lines be parallel? The lines will be parallel if your alternate exterior angles are congruent. So if the alternate exterior angles are congruent, then the lines are parallel. If we have a transversal and consecutive interior angles are supplementary, this is the one that's different. This is the supplementary one. These angles have to add up to 180. Then the lines are parallel. If consecutive interior angles are supplementary, then lines are parallel. So we're proving lines are parallel, and we did that by knowing that the consecutive interior angles are supplementary. We have one more on the previous page even. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. If corresponding angles are congruent, then lines are parallel. So if you know that, then we know we usually put arrows on a line if we know they're parallel. Then the lines are parallel. So that tells us what these converses are. So as we go back to our proof, alright, currently this is on page 19. Now we can talk about this alternate exterior converse. So what we're going to do is know that we're showing they're congruent. For us to prove the lines are parallel, we have to be able to say that the corresponding angles are congruent, because that shows parallel. That's the postulate. So this is our given, and from our given we can see that angle 2 and angle 3 are vertical angles, so they're congruent. Because 2 is congruent to 7 and 2 is also congruent to 3, I know that angle 3 is congruent to angle 7. And 3 and 7, these are what type of angles? These are corresponding angles. And if corresponding angles are congruent, then the lines are parallel. Here, this is a little bit different. It's not a proving a current theorem. This is just, in general, we want to prove that A is congruent to B. What we know for sure, and sometimes it's difficult for us to keep track, what we know for sure is that X is parallel to Y and that 1 is congruent to 3. That's what we know for sure. What we want to show is that A and B are parallel. Well, let's think back. We've got to make a plan. If A and B are parallel, for that to happen, 1 and 2 have to be congruent. So I have to get 1 and 2 congruent. If these two lines are parallel, X and Y, then I know alternate exterior angles are congruent. So I know that 2 and 3 are congruent. Therefore, 1 and 2 are congruent. Therefore, the lines are parallel. I made a plan. You've got to make a plan before you start your proof. So, X is parallel to Y, and we also know that angle 1 is congruent to angle 3. That is our given. The reason for angle 2 and angle 3, what would we write as our reason? Why is 2 congruent to 3? They're not vertical. Lines are parallel. So if lines parallel, then alternate exterior angles congruent. This is what we learned yesterday. Now we know that 2 and 3 are congruent. We already know that 1 and 3 are congruent. So 2 and 3 are congruent, 1 and 3 are congruent, so now I know that 1 and 2 are congruent. What allows us to say that? Transitive property of congruence. Okay, now we know that 1 and 2, and what type of angles are these?